Hello, my name is Suchita Tork. I am doing the extra credit homework. I'm going to be talking about nodal analysis. So nodal analysis, before we start, you need to have a background on KCL. So the sum of all your currents in a closed system or circuit should be zero. And the whole point is to find the voltages across non-reference nodes. So if you want to find at a certain point, instead of over a resistor, then you can use this concept to find your voltage. So some steps are you want to select your non-reference nodes, apply KCL at those nodes, and then after you get your equations, depending on how many unknowns you have. So for example, if you have two, then you want to have two equations. And then after you get those equations, you solve. Yeah. So why do we do it? So I drew two different circuits. So the first one, you have let's start from the bottom. So you have a current source and your currents are splitting over R1 and R2. And we know that in parallel, the current has to split up, but the voltages across those resistors have to be the same. But let's say, for instance, we want to find the voltage across at a certain node, and there's a resistor in between them. So on the top, right, we have the current and splitting up, same scenario, but there's a resistor in between. Therefore, having V1 and V2 should not be equal to each other. And this is important because, as I noted before, they have different currents since it's in parallel, and there should be different voltages along individual resistors. So along all these resistors, unless they have the same resistance, they should not equal to each other. And especially for the first one, where we have R1, if let's say I have 10 volts across that resistor, then the sum of the resistors where the voltages are going across them for R3 and R2 should be 10 as well. So for the second one, different currents, but they have the same voltages along resistors. And then, so to apply for that top one, I guess it's going a little bit off tangent, but if you want to find a certain voltage across a resistor, then you have to find your V total, which sometimes you can find your non-reference node. You put it across the resistor you want over your total resistance. So like for instance, if I want to find the voltage across R2, I know my total voltage. Let's say if I know my total voltage and I have these unknowns, I could put in the equation and then find it for R1, R2. One important thing to know is for nodal analysis, you need to know the difference of potentials. So the voltages at where you started minus the voltage where you ended off at. Usually voltage for final should be zero, and your resistor should be where you're going across through. Essentially, it should just be a current, and you're just tracing your finger along the circuit, and that should be whatever component of I you want. So I use an example. So I just chose 3.1 practice problem. Some things to note is when you follow the steps, you find your reference node V2 and V1, which is indicated right here. And you apply KCL at those nodes. So I want to find KCL at V2, so I know that I am starting with the current source and it's splitting to big I2, small I2, and then small I1. And that's my first KCL equation for my non-reference node V2. And then for my second one, because I want to find out V1, I know there's a current source at the top at 5 amps, or big I2. And my small I2, which is going horizontally to the left, that should equal I3. And then those are set up my two equations. Since I have two unknowns, have two equations, I'm pretty much set. So I'm going to plug it in. So 10 amps for big I equals 5 amps plus my current going down, which is I1. So it's V2 right here, which I'm called before. I'm going to trace it down, V2 to 0, because it's my ground, over my 6 resistor. And then I'm going to call I2 V2 minus V1 right here over my 4 resistor. And then I can call that I2. I'm going to do some algebra right here. And then I should simplify should equal 60 equals negative 3v1 plus 5v2. That's my first system equations. Then I'm going to do I2, big I2 plus I2 equals I3, which is my next KCL. So I2 it was explained before, so V2 minus V1 over 4. And then I3 is V1 to ground, which over my 2 resistor, which should be my I3 current. So I simplified, I got to 20 amps equals 3V1 minus V2. So if I plug into my system equations, which I should have set up already, negative 3 V1 plus 5 V2 equals 60, and then 3 V1 plus negative 1 V2 equals 20. And just want to make sure, double check, negative 3 plus 5 equals 60, 3 minus 1 and 20. I equal, oh, I want to solve. That's my voltage, so V2 should equal 20, and V1 should equal 40 over 3. And we know this should make sense because V2, if it's at 20 and V1 is 40 over 30, which is about 16, then we know it's going from higher potential to lower potential, and we know that we are conceptually correct. And then this is my voltage. Let's say if you want to check if you're correct, right? So apply it back to your KCL. So I know for my first equation, I1 equals I2. Oh, I1 equals I2 plus I1 plus I2. So I know it's 10 amps equals 5 amps plus I1. And I know I1 is V2 over 6. So I'm going to do V2 over 6, which is 20 divided by 6. That's 3.33. Cool. And then I need to do my second one, I2. So V2 minus V1. So I'm going to do 20 minus 40 divided by 3. And I'm going to divide that by 4. That's 1.667. If I were to add those values, 1.667 plus 3.33, that's 5, plus I2, which is 5, that should equal 10. Therefore, it should equal to your current source, and you should be correct. And that's it for the video. Thanks for watching.